we're going to do here is to train the robots on the concepts of life and general tasks which you would require. So, for example, if you're carrying a heavy weight, for example, in a hospital versus, for example, in a store, it's the same little thing. How do you go about it? You might sort of bend down a little bit and grab the item, then stand up, for example. Same task, right? Why not just train those basic items of lifting, shifting, moving, packing, folding as concepts to the robot so that it knows, and then finally be able to apply them in different purposes.
Major hurdle in the robotics industry is developing robots that can adapt quickly to new tasks and environments without needing extensive retraining. This challenge is especially relevant as robots are increasingly used in dynamic fields like healthcare, warehousing, and customer service, where they must handle a variety of very unpredictable tasks. Now, researchers at MIT have introduced a groundbreaking approach that could address this issue by training robots using diverse data pulled into a single system, making them more adaptable and versatile. But again, here we're coming to that whole generalized versus specialized kind of task. So I don't know, Raj, what are your views on this straight off the bat?
Well, Megan, firstly, I'm excited about this opportunity and this big growth potential with robotics getting as available and sort of be able to use for diverse purposes, like we can use, say, OpenAI, ChatGPT, or other AI tools for, say, the software side of things, or for content writing, for example. If there wasn't diversity in them, they would be totally useless. Similarly, if we don't really have diversity available within robots, then just a robot trained for just one task, say stacking the shelf in a shop, doesn't really help a business to achieve maximum productivity from these robots. So having general purpose training available and them knowing the lay of the land a little bit will just help the robots to be used in a better way.
Now, before we kind of dive in, what does this mean in terms of specialized versus the diverse or general robotics? Because obviously, if I'm going to have a brain surgery that is done by, powered by AI, I don't want one that was packing shelves at Walmart and now it's kind of just downloaded an extra little bit of information and is ready to do brain surgery. There is obviously still a need for specialized robotics.
Well, I mean, that reminded me of a scene from the movie Matrix where Neo had to ride a helicopter and he didn't know how to do it, so he just downloaded a instruction manual to write it, right? So that is what literally is happening at the moment with these robots. But kind of answering your question, if you look at, for example, a brain surgeon or someone stacking the shelf, they both need to understand alphabets, numbers, those sort of basic concepts. So what we're trying to do here is to give them the basic training so they can understand the lay of the land a little bit and not be have to train every time, especially for a particular task. But that's very time consuming, and perhaps use this for businesses overall. Why would you want to just get robots to do this one task for you? If you have a general purpose training available so you understand, for example, well, if there are kids near me, I have to be careful. If somebody says, excuse me, and respond to them, all these bits are just general courtesies which we human beings know because we have been trained and we observe. You see, as kids, imagine trading time. You're doing stuff as a child. You have, I don't know, 200,000 hours of training of just looking at people doing different things, right? But these robots don't have that. So you just train the robot on basic ways of being, then they can be useful for different tasks. And you have to train them minimal amounts to kind of be able to shift them from stacking shelves in a shop to packaging and packing stuff for the customers in a supermarket. So I think that's a very exciting opportunity.
Yeah, yeah. Now, diving into the way this training model is actually working, if I'm understanding correctly, it's taking inspiration from large language models. In what ways do you think treating robotic data like language data could improve robots' ability to learn and perform really complex tasks?
Yeah, as I mentioned, the fundamentals are super important. When I was doing programming at university, I was taught like don't learn the syntax of the programming language, learn the concepts. And really, what you're trying to do here is to train the robots on the concepts of life and general tasks which you would require. So, for example, if you're carrying a heavy weight, for example, in a hospital versus, for example, in a store, it's the same little thing. You know how do you go about it? You might sort of bend down a little bit and grab the item, then stand up, for example. Same task, right? Why not just train those basic items of lifting, shifting, moving, packing, folding as concepts to the robot so that it knows, and then finally be able to apply them in different purposes. I mean, that's very exciting. That's where we want to be going about things. So overall, it's very exciting for us to kind of build that large language model approach to our life and move it to hardware or robots, which is one area which if once changed can help so many people. Imagine all the people who in elderly care homes, for example, who need robots to make life easier. You could be living away in a remote farmland or in the middle of nowhere and still have your life taken care of because you have robots helping you out. So the use case of this just in our lives and not thinking about military and industry itself is humongous.
Yeah. Now it's interesting that you've said, let's look at the concept rather than the specific instruction or the specific task, because that's a very human thing to do. I like talking about transferable skills. You work on something, you learn how to do it, but then you can actually apply that particular framework to something else. Like taking a three-act structure of a fictional story and applying it to writing a technical case study, for example. The framework is the same if you understand the fundamentals. So that is a very human thing. It's interesting how robotics is becoming a little bit more human because we're essentially giving them transferable skills now.
Absolutely. Well, if you think about like my main role used to be innovation, and I often joke that innovation is just remixing different irrelevant items, right? So one of my previous roles, I built a software to help people fix their computers and iPads and iPhones. Literally, I took an app where they taught how to dance salsa, and I took that and I mixed that with like an app, and that became like a new app to fix your own computers. So really, it's all about remixing stuff, right? And so even with robotics and AI, it's now remixing the different abilities because you're right, the concepts are the same. Whether you apply them to content writing or you apply them for medical purposes, they're the same concepts at the end of the day.
Yeah, yeah. Now, by reducing the need for task-specific data, this technique could lower training costs and time. Do you think that this will make robotics more accessible for smaller businesses and organization? And is that going to impact the adoption of robots in everyday settings? I mean, we've seen how AI, generative AI costs have come down and it has become kind of more accessible to the general public and general small businesses, etc. Are we going to see a same trajectory for robotics?
Absolutely, absolutely. I often, when I go to my workshops talking about AI, I often tell people that soon the reality is going to be like this. You're going to have one department with one department head. That's mean the one human being you're going to have in the department. Then you're going to have all robots working with you. Now with this technology, when it becomes available and it's sort of properly trained, for example, then it becomes an ability that we not only manufacturing in content production or marketing can have this, but also, for example, in factories can have this as well. You'll have people using this in small shops to get mundane tasks done. You'll have people working in the hospital we talked about before, restaurants, for example, as well. Already, I'm sure you've seen a lot of robots running around cleaning stuff in airports and restaurants. So there's much more to
Mm.
happen and make them a bit more diverse, for example, and a bit more agile in what they can do.
Yeah, I was traveling recently and I was at Schiphol Airport and there were these or autonomous wheelchairs taking mobility disadvantaged people around the airport, and it was something like out of a sci-fi movie. So yeah, I mean, it's here. It's just not widely adopted yet. So yeah, the future is now, essentially.
Absolutely, and I know I'm looking at these, like, these rubbish clearance autonomous beings in the airport, and I'm like, why aren't they talking about other things they can do as well? For example, they can be reporting people, like helping people who are lost, for example, in the airport, or for example, they can like point out there's a security breach in the airport. I mean, they can do the different items as well. Suddenly, you can do that with these different tools because they have both intelligence as well as the manual capability of doing things. So it's
Yeah,
pretty
yeah.
impressive.
That's a great kind of segue into my last question, because obviously looking ahead, the idea of a universal robot brain is quite intriguing. It's powerful. There's a lot of opportunity, but there are still challenges. So, what do you think researchers might, obstacles that researchers might face in making this reality? And again, from a safeguard perspective, what safeguards would be needed to ensure that these robots are both safe and effective in diverse environments? I mean, you don't want to obviously necessarily go up to a robot in an airport because you don't know where the gate is, and it ends up reporting you because you look suspicious, and you end up getting chucked into security holding cells. So, what sort of challenges can we expect, and what's guardrails are going to be put in place for this?
Well, it needs thorough testing. I mean, this can't be deployed tomorrow in airports or hospitals or shops. You do a lot of testing to kind of check out what is possible with these tools. And when you do testing, there will be times of like how does it infer items, how does it react to different things, for example. All these things will take some time of trial and error, but then also training it to not do some items. Again, we have seen this in LLMs, how they were able to almost take out responses which were not human friendly or not desirable, for example. And that's also possible in robots as well. You can actually just tell it to do certain things and not do other things, and how to react to certain problems as well. So
Mm.
again, LLMs are a great way to educate what we can do now with robotics and AI.
Yeah, yeah. It's going to be interesting to see how this affects regulations, or how regulations, which is also a very changing landscape, is going to affect this. If you're interested in how what's going on in that, join us in the next episode where we dive into the regulation side. But otherwise, we want to know, what's your take? Are we moving closer to a world where robots can handle a variety of tasks seamlessly, or are there still too many challenges to overcome? We'd love to hear your thoughts. Please pop them in the comments. And as always, if you enjoyed today's episode, don't forget to follow, subscribe, or share. And thanks for tuning in. We will see you in the next episode.